Hi everyone, welcome to this week's Udacity Deep Reinforcement Learning Nano Degree weekly webinar. This week I'm going to focus on the continuous control project, which is your second project and is part of the policy methods. Now, hopefully, we've all gone through the navigation project, and now going on to the continuous control, we'll be using a continuous action space environment. So it's going to be a little bit more difficult, and you'll be using some more complex algorithms and probably policy-based algorithms to be able to achieve this, as the deep queue would not be able to do this at all. Or you have to do some crazy stuff with changing the actual action space to be able to get it to work. Anyway, let's continue on and get onto it. So first what I'm going to do is just go over what we will cover. So I'll go over the project instructions, project overview, evaluation, project submission, rubric, where to start, make your project stand out, code walkthroughs, environment setup. So I'll basically be going through Windows, Mac, AWS. I'll go through the project work through using the workspace, and I'll give you some extra hints that I would say will help with this particular project, and just go through some of the stuff that will help you maybe get started. So, all right. First off, let's look at this project. So the project is a continuous control project. So your agent, so basically what you need to do is, like the original one, is for this particular project, is train an agent to solve the provided environment, which is the Reacher environment, which I'll go through later. You have to submit the project either through a Git repo or as a zip. You have to go through the rubric, which I'll go through later. And basically you can do, as long as you achieve the goal set out by the project, you can pretty much use any algorithm you want. So you could use DDPG, you could say A2C, you could use PPO, you could even use, if you want to have a try implementing it, the SAC, soft actor critic. But we'll go on to the next bit. So basically with the project, I'll go over what is, so basically you need to train an agent of a double jointed arm, can move to a target location. You get a reward of 0.1 for each step that the agent hand is in the goal location, so as it's following it. Thus, the goal of the agent is to maintain its position on the target location for as many time steps as possible. The observation space consists of 33 variables corresponding to position, rotation, velocity, angle, velocities of arm. Each arm is a vector with 4 numbers corresponding to torque application to joints. Every entry in the action vector should be a number between -1 and 1, which would work really good with a soft actor critic if you want to have a go at it. So you also have distributed training. So for this project, we'll provide with two separate versions of the environment. The first version contains a single agent, and the second version contains 20 identical agents, each with their own copy of the environment. Second version is used for algorithms like PPO, A3C, and D4PG that use multiple non-interacting parallels copies at the same agent to distribute the task of gathering experience. So, solving the environment. So, solve the first version of it, which is the single. The task is episodic, and in order to solve the environment, the agent must get an average score of +30 over 100 consecutive episodes. So basically the mean of the average, of the score over 100 consecutive. And the second is slightly different, to take into account the presence of many agents. In particular, agent must get an average score of +30 over 100 consecutive episodes of all agents, which can make it a little bit more difficult, but honestly, it's not that much harder. After each episode, we add up the reward that each agent received without discounting to get a score for each agent. This yields 20 potentially different scores. We then take the average of these 20 scores. This yields an average score for each episode, where the average is over all 20s. The environment is considered solved when the average over 100 episodes is +30. So basically, you just have to add up all your rewards and then mean it over 100, and basically see if it gets plus 30. So the project will be reviewed by the Udacity reviewer against the project rubric. Now, the rubric's really important, especially when you do projects. Now, if you've already done one project, you'll find that you sort of understand this, but I'm going to go into it slightly. All the criteria are found in the rubric must meet specifications for you to pass. So everything. So look through it. So if we go on to that now, and where is it? So here is the rubric. So it's split into 3 sections, basically the training code, the README, and the report. The training code is pretty straightforward. Have all your code documented, organized. Framework has to be in PyTorch and Python 3, and submission includes saved models and weights of a successful agent. Now the README. The GitHub submission includes a README. It has the project details, get started, so installing dependencies, downloading files, all of that. And the README describes how to run the code, and all done in Markdown. The report. Now this is where some people get a bit stuck. The submission includes files. So basically, you do either report.md, report IPY, and put a part of your IPython, make a PDF. But basically, what you need to do is report clearly describes the learning algorithm along with the chosen hyperparameters. Also describes the model architecture. So talk about the neural network and explain what the algorithm does and why you chose particular hyperparameters and why others didn't work. You have to have a plot, of course, that we can easily see what's going on, and have some future ideas of what else you could change. So say if you did DDPGs, maybe that you would change something in it, or that you would have a go with PPO, or just anything that to make it maybe even better again, and what you would change to it. Okay. So the GitHub submission. So as described in the rubric, your GitHub submission should contain a README that describes how someone not familiar with the project can use the repo. So basically just explains how to set it up and get going. Has the code, train model, and a report as described. We suggest that you submit the GitHub repo, but you can do it as a zip file instead, and basically show what's on when you go to submit it. Zip up the file and send it through. But I wouldn't recommend that, and you should be probably getting your GitHub ready as part of the. It's always good to have good GitHub running anyway. So where to start? Well, first thing I would do is I would actually go to the repo. Now the repo is part of the deep reinforcement learning, Udacity deep reinforcement learning. Have a look at that, go to continuous control, and see this is basically the reacher arms trying to touch that. It's got a lot of the information that I've explained through. It's got the environments for different versions and also the different operating systems, and basically has some like versions for no screens, which you also get in the workspace. Now this is the optional challenge, which I'll talk about a bit later, but we'll go on to that. So first thing I would do is master the details of DTPG. That will be the easiest one to get going. It does take a while, and I would say that you might take 6 to 8 hours, even longer, to train, depending if you use GPU or CPU. But basically go through the paper and go through, and try to get your head around it. So study the coding exercises for the lessons. And when I talk about, so basically go through the DTPG that's available, take time to understand the code in great detail, and tweak hyperparameters to see what's going on. So if we go back to here and we have a look at the Udacity, let's have a look at the DTPG bipedal. So if we go into this, let's open it up. It's basically, it's importing dependencies, it's making a gym, which will be slightly different in the Unity environment, but same idea. You've got an agent, and basically here it's running a loop. That's the loop, the main loop, which gets the rewards and works out the score and prints it out. So you'll be doing a very similar thing. Have a look at this one as well. Same deal. Almost identical. So initiate state, environment, and go through and print it out. Now I'm going to go to back to here, and we'll go through that in a bit. But probably one of the things I would recommend is under the DDPG is go back and look at the actual code. It's broken down. So here is the main area for DDPG, the agent. So it has, as you can see, read through this and really get this. So you've got your hyperparameters here, your gamma, discount factor, you've got your learning rates, you've got your weight decay for L2, buffer size, all that sort of stuff. Very similar to a deep your navigation project, but as you can see here, you've got an actor and a critic network. You've got your steps, you act, you reset, and you learn, similar. Soft updates, and now you've got this OU noise. So I would recommend looking at those two and changing them up to double to 10 times in various directions, and just see what that does to your scores. It's quite makes quite a difference in some environments. Okay, so definitely get your head around this. Definitely go through this one as well. So have a look at the models, what they've implemented, and do that on both, and just have a bit of a squiz through how it has been set up and what you might need to change. I will tell you now that running just copying the code from here and here and implementing it into Unity and the other environment, it will not change. You'll have to go into it further than to model and the agent. You'll have to tweak it. It's not that simple, and pretty much with deep reinforcement learning, you're going to have to modify everything for just about every environment. And even changing the action space or the state can make such a big difference in your parameters, like just insane amounts just for such a small amount. So let's get back to the actual PowerPoint presentation again. So again, adapt the code from the lessons as I have just gone through. So basically, the first thing all you want to do is get the code. If you get stuck, implement it, get it working with the environment, make sure it runs with no errors. Don't change anything. And then once you've got it working, then start playing with it. Start changing OU noise, start changing batch size, model, whatever it is to get it working properly. You're going to have to change the main loop anyway slightly, and the way it gets the scores, just little things, but just see if you can get it working. And if you've done a navigation project, you'll find that quite easy, I would say, much easier than doing the first one that you tried to implement. Then yeah, go through and optimize parameters, but it's going to take a while, and I'd recommend using a GPU. And then continue to explore, go through different algorithms, see what else you can try. Definitely, if you have time, use PPO. I'll tell you now that you can get it training in about 16 minutes. And I've seen a student do that with incredible scores with their own implementation. But if you don't have time, or you want to try DTPG, which will definitely be the easiest one to start off with, go there. And if you've got time, try some others. We'll try using, say, some stable baselines, but and play around with them using soft act critic. Just have a go at different ideas. Now, make your submission stand out. So you can do a normal submission, do a DDPG. I would say if you can do a YouTube video, the train that, or solve it under 150 episodes. I've heard people doing it under 100, but that's a good challenge. Write a blog post, explain the project, implement DDPG and also A2C or PPO, depending on if you're using the 20 version or not, but even after just having a go at it. And also maybe have a go at the crawl environment, which I'll go through as well. So the optional challenge, the crawl, is, if I go to here, is this one here. So it's basically teaching a little spider to walk along. Actually, it's funny, the thing that got me into deep reinforcement learning is seeing one of these things sort of learning, not this particular one, but you know, seeing something learn to walk, and it just made me think about something that I've been working on for quite some time, a spider deep reinforcement learning robot that does some stuff, and you know, it's one of the things that kind of triggered me into the industry, or one of the things. So now if I go back, so pretty much same deal, download it and you have to get it to walk, and you know, only do this if you submitted the other project and passed, otherwise, and you know, or even do this after you finish the course, just to have some extra skill sets. So now I'm just going to go about environment setups. So first thing I would do, like I said, is go to the Git repo of continuous control and go through all of that. So if you go to here, this is it. So it's got all the details, solving the environment, it's got the get started, and you know, you can follow that. First thing you look at is what is available. So that's for the crawler, that's for the continuous control. And if we go through, pretty straightforward, which I'm then going to go through more of this later, but you know, read through it, get used to all of this, and see what's going on. So first thing I'm going to do is, here's the continuous control. So this is in a project environment. So if we go, all right, I'm just going to trust it as well, make sure it's all happy, and that seems to cause me problems. So we run the code, it's going to do a pip install. You're going to get set up, run that at some point, hopefully. Struggling with it, isn't it? There it goes. Give it some time. So basically what it's doing here is doing an install file, getting everything that it requires to run. As you can see, it does seem to be taking, and I'm just running this in non-GPU mode at the moment as well. And I would recommend also, when you're setting up your environment, don't run in GPU until you've actually got everything working, so you don't use your GPU hours, and then just let it run. Now, potentially it's not running because I'm running Edge just at the moment and not my normal Chrome. I do find that I can have issues, but, oh, there it goes. So next, so basically it's going to import Unity agents from Unity environment and NumPy, and then it's basically going to set up the environment from that file. So you have to put that to the, you know, where you want it, or what file that you're going to be using, depending on your version. So that's very straightforward. Run it. Bang. So it's giving us some quick printout of what's going on. And now we're going to set up the default brains for Unity. And now we're going to look at the action space and the state space. So as you can see, there's one agent. Size, because we're using the single version, we've got each size of each action is 4. There are one agent. It observes a state with a length of 33. So this is the details. So here is it just running a random actions in the environment. Shouldn't do very well, and no, I did pretty poorly. And then you can close it. So what I would recommend is looking at these implementations and seeing how you can maybe first put that through to that. All right, next. Gone through the workspace. So local install in Windows. So probably the first thing to do, which it actually says Linux dependencies, but it's meant to be Windows, is go to get the repo, activate an environment with Python 6, conda create it if you can, activate it, git clone, then as your next command, this. Oops. Then cd into deep reinforcement Python, do a pip install, you get errors, conda install PyTorch TorchVision, and then pip install Unity agents, and you should be fine for Windows. So just follow that, very straightforward. I find that easier than what's on the Udacity Git repo. This is a straightforward way of doing it. You would then get basically go to here, create a folder for download it, create a folder for the project, move to the project, download the environment, unzip it, move the environment file to the project folder, run the Jupyter Notebook, run through the cells, checking for any errors. And I was going to do a live setup, but I did that with the original navigation project, and you pretty much do the same from that one. So Linux and Mac, pretty much even more simple. Download the actual, go to the Git repo, first create an environment, activate it, git clone that, cd into the Python directory and do a pip install. Basically, then you just need to download, go to this page, create, download it, move to the continuous control project to the folder, download the environments or noviz, unzip them, move the environment file to the project folder, run the Jupyter Notebook, run through the Jupyter cells, and once again. Now, an AWS setup, I would say go to here, get this particular environment, and from the community, and search for the AMI. Get a P2 extra large, open up port 888, launch the instance, and create a key. Then basically, once you go into it, SSH into it, source activate Python 3, git clone it, cd into Python. Once again, pip install. You'll have to pip install Python. You'll then have to cd into the continuous control and wget the noviz or the multiple version. Apt-get install unzip, so you can then unzip it, and then just run the Jupyter Notebook with no browse, with allowing 00. Copy the URL from the terminal, replace it IP with external IP, and all of this is in the. I've actually done a full live demonstration in the navigation project webinar. So if you want to go back to that and watch that, but there's no need to double up on the information. Now, some hints. Now, if you get started and you can't train it, change the args in the OU noise class and have a go at changing them quite a bit. Also, change or remove L2. I found that seemed to help sometimes. Change the batch size can make a big difference in continuous control spaces. I found it with this one, and try some different algorithms. So I'm hoping that gives you a good idea. It's a little bit more brief than the navigation, as you should have already got through a project and understand it. But it is a much harder project, like much harder. So I would highly recommend pushing through this. And if you have any problems, message me. I've got lots of hints and extra reference material that can show you. But for now, I'm going to do a Q&A. And if you guys got any questions, let me know and I'll answer them now. Otherwise, I'll answer them on Slack during the week or later on. So Q&A. So, ask me if there's anything else that, anything you're not sure on that you maybe got from the first project or something that you'd like to know. Otherwise, I'll let it be for the day, and I'll talk to you all during the week. So I'll give it a couple of minutes, maybe 30 seconds. Well, looks like no one really wants any questions for this particular project. So thank you very much for watching the webinar. I'm excited to see what you guys are going to create with this project. And yeah, have a good week. Right, thank you.